Hello, everyone, and thanks for joining us. We're going to be going over making, let's have fun with equivalent fractions. So we're going to be making math fun. So this is designed for third and fourth graders to explore equivalent fractions with teacher Georgia. Thank you so much for joining us. So give us a little bit of background on what we're going to be doing.
So we're going to be starting by just you telling me what you already know about fractions. So what do you know? What do fractions mean? Maybe how you've seen them in the real world. And after I get a good idea on what you understand about fractions, we're going to move on to equivalent fractions.
So go ahead. I went ahead and dropped the link in the comments, and I also have that on the screen to go get the follow along freebies with this class so that you can be able to follow along as Teacher Georgia guides us through equivalent fractions. And then I'm also sharing an exclusive offer to join Tampa Bay Test Prep for an introduction to third grade math on October 10th. That is 3 p.m. Eastern Time. So I went ahead and shared a link to be able to get access to that free math class. Okay, so go ahead and share in the comments where you're joining us from and who you have joining us today. I'm actually joining from Arizona. Georgia, where are you joining everyone from?
I am joining from Iowa.
It looks like we have someone joining us on the Homeschool Quest Facebook page. Hi. Don't be shy, say hi in the comments. And if you guys are not familiar with Tampa Bay Test Prep, they have amazing curriculum options and classes for math so that your kids can be totally prepared all the way from pre-K all the way to 12th grade. So they have amazing resources. I'm going to go ahead and drop a link to their website so you guys can take a look at all of the different great stuff that they offer as well. Okay, I think that we're ready to get started. So I'm going to switch over to the screen share. So, hi, Devin.
Hi, Devin.
Okay, let's start. Let's share in the comments what you know about fractions. Teacher, Georgia, why don't you take it away from here?
All right. So first of all, just I want you to think back to what have you already learned about fractions? Do you know what's a denominator? What does that mean? Have you heard the word numerator? Well, what does that mean? What does a fraction represent and what does a fraction mean? How could you explain that to somebody who was just new to learning about fractions?
Hi, Ty. Thanks for joining us. So, Teacher Georgia, it looks like we have a couple more people that joined. She was just asking you guys to share in the comments what you already know about fractions and how you would explain fractions to someone who doesn't know what they are yet. So Ty says that it is the bottom number.
Hmm. The denominator is definitely the bottom number. Well done. If the denominator is the bottom number, then what's the numerator?
It looks like we have someone joining us on YouTube. Say hi in the comments.
While we're waiting, another question could be, where have you seen fractions in the real world? I I see fractions all the time in my kitchen. I'm wondering if you see examples of fractions in your kitchen as well.
Yes, I would say that I use fractions the most when baking or
Hmm.
like a recipe.
Yes.
So, shall we jump into the introduction to fractions? Let's have some fun.
All right. So, if you had mentioned, I saw somebody, I think it was Devin or Ty. I'll get that figured out. So noticed or made a comment that the bottom number was the denominator, and that's absolutely right. So another way we can think of that is that's our total parts. Maybe you already know this, but if you do, it's a good refresher. So if I have 1/2, that just shows me that my picture or my object is um, split into two equal parts. If I have a fraction over here, I like to look at these rectangles. They make me think of brownies. I'd like to think in terms of food. So if I had a pan full of brownies and my fraction was 1/6, that 6 tells me, well, there are 6 equal pieces to my brownies. There's 6 equal parts. So if we look at that as the denominator, that is our total equal parts, then we can look at our numerator, which means how many parts are shaded. Or you might hear with my brownie picture, how many parts have been eaten. So if I look over here at 1/6 and I come over and eat 1/6, that one represents I ate one piece out of the total 6 pieces. So now, what if my daughter then came over and she noticed that her mother had been into the brownies, and she might think to herself, well, what fraction of the brownies are left? And we can see there's 1, 2, 3, 4, 5. There would be 5 parts of the total 6 that were left for her to eat. So we would change that or write it as 5/6. So that's just a kind of a quick overview of fractions. But what I really wanted to get to today are called equivalent fractions. And I have a question for you. They have kind of a fancy math term here. They're called equivalent fractions, and I'm kind of curious if anyone sees a little word in the big word. I keep moving my frame around. Let's try this again. A little word in the big word equivalent. They could maybe hear a smaller word in the word equivalent that might help us with what they mean.
Is that word equal?
That word is equal. Yes, equivalent fractions, it's just a fancy way of saying I want two sets of fractions that are equal. Equal means the same. So let's take a look at our little friend here. Got a little squirrel sitting here. So we're going to go back to our brownies because once again, I do love food. So I want to represent 3/6 of the brownies. So that tells me that my pan or my rectangle in this picture are divided or split into 6 equal parts. 1, 2, 3, 4, 5, 6. That's good to go. My numerator tells me that 3 should be shaded. So I'm going to take my highlighter and I'm going to shade 3 equal parts. It's not going to be perfect. Luckily, this isn't coloring class. So I've represented or shown 3/6 of my model. Now I want to make an equivalent fraction. I want the value or how much that's shaded to be equal or the same. So if I go through here, kind of think as you're watching, see how many I would need to color in a model or a picture that now is cut into 12 pieces. So if we think about these as brownies again, this time I've cut them up into 12 equal parts. So as I'm coloring here, do you notice that even though this is 3/6, 3 parts shaded out of a total 6, and this is I'll let you guys count that. How many parts did I shade in this model? If you were to count how many I shaded or I colored, how many equal parts did I color? Okay. If you said 6 and I didn't hear you, then you are correct. We have 1, 2, 3. Hey, okay, I do 2 people. Yeah, I have 2 people said 6 parts. 1, 2, 3, 4, 5, 6. So I'm going to write 6 here in my numerator. I am going to say that 3/6 is equal to or equivalent to 6/12. Yes, I have different equal parts, but the amount shaded, the total value is exactly the same. So if teacher Georgia ate 3/6 of the brownies, it's the same as saying I ate 6/12 of the brownies. So let's move down here. And as we're thinking about these equivalent fractions, we're obviously not going to be coloring bars our whole life. So there's also another little trick to figuring out equivalent fractions where we're not having to color in the bars every single time. But we're still in coloring mode right now. I will look at chat though, because if anyone can think of a pattern to help us figure out equivalent fractions without the bars, let me know if you figured that out. So if I look at number 2, I am supposed to color in 2/3. So that tells me, my highlighter out again, I want to color 2 parts out of the total 3. Okay, hope everyone giving me a thumbs up right now. Now I want to make an equivalent fraction. I want the same amount colored in, even though my next bar is 9 equal parts. Definitely different than 3 equal parts. So I'm going to color this in here, and I'm going to kind of keep one eyeball on chat, see if I can keep one eyeball on chat and one eyeball on my screen to see if anyone can tell me what my numerator will be for my equivalent fraction. I know 2/3 is my fraction. And then I want to know, oh, that's kind of interesting. I see a similar answer. How many equal parts are colored in my equivalent fraction? How many out of 9? All right. 6 again. So 1, 2, 3, 4, 5, 6. So 2/3 and 6/9 are equivalent. Let's do one more and then let's talk about how we can figure out equivalent fractions without coloring in models over and over again. So I'm going to scroll down just a little bit. I kind of want to still see everything. Maybe a little bit bigger here. Thanks for your patience with me. So I'm going to actually skip down. I'm actually going to skip down to number, which one should I do? Let's do number 5. So we're going to look at our fraction is 1/3. So as you guys know, you're probably seeing on the other side of the screen, we have to color in 1 part of the total 3. Can someone help me with an equivalent fraction, but this time my bar is cut into 6 equal parts? Hopefully we get a different numerator this time. So without me coloring it for a few seconds, how many equal parts will be equivalent or equal to 1/3? Okay, so as you watch me color, okay, I'm noticing that if I have 1/3, even if I kind of draw a border around it just to make it a little more easy to see, this is the exact same value. Yes, the top one is in 1. I see 2 parts. Exactly. That is perfect. So 1/3 is equivalent to or equal to 2/6. Okay. So if someone had eaten 1/3 of my pizza and someone else had eaten 2/6, they're eating the same amount. They're eating an equal amount. So now let's figure out, I'm going to go to a blank page for a minute. I'll make it a little bigger here. And then I am kind of curious, if we look at some of these fractions that we already decided were equivalent. Actually, I changed my mind. I want to stay on the same page. Is that okay if I change my mind? I'm going to write out the fractions that we already did. So we have 3/6, I'm just going to write off to the side here, is equal to 6/12. We also had 2/3 is equal to or equivalent to 6/9. I'm just looking at the pictures that we've colored already. And down here with number 5, we have 1/3 is equivalent to or equal to, what did we say? We said 2/6. So just looking at the numerators, check the numerators together. Like for instance, the 6 and the 12. Look at the numerators. Look at the 3 and the 6. Does anyone notice a pattern of how we can get from 3 to 6 or from 6 to 12? What kind of math would we be doing to make that change? I'm going. Okay, multiplication. I was going to give a hint, but I don't even have to. We absolutely will use multiplication. When I first start with equivalent fractions, I just draw some pictures here to kind of help our brain stay organized. So I'm thinking to myself, 3 times what number would equal 6? So I'm using an unknown. Does 3 times 1 equal 6? 3 times 2 equal 6? Does 3 times 100 equal 6? So as you're thinking through your 3 facts, I'm going to pop in here and I'm going to say, well, 3 times 2 equals 6. Let me know if I'm wrong here, but 3 times 2 equals 6. Now, if it's an equivalent fraction, whatever I do to the numerator, I have to do the exact same math to the denominator. So I'm going to put my little line here. Remember, that just keeps my brain organized. I'm going to, yes, 3 times 2, excellent. So now let's see if these are equivalent. 3 times 2 equals 6. 6 times 2 equals 12. That lets me know that these are two equivalent fractions because we're making the same change with both fractions. Now what I've realized is I crammed too much in one space. So I have to erase this. Let's try the same pattern now with the other one. So we had, I'm going to give myself more room this time. 2/3 is equal to or equivalent to 6/9. Okay, it's the same math. Whatever we multiply by the top, the numerator, we have to also multiply by the denominator. That would mean it's an equal or equivalent fraction. So I'm going to watch in chat. Let's start with our numerator. 2 times what would equal 6? All right, I bet I'm going to see some answers pop up. So I know because I've worked on my times tables, 2 times 3 equals 6. If this is an equivalent fraction, that means I'm also going to be able to multiply, I see that 3 up there, I'm also going to be able to multiply my denominator by 3 as well. Let's check it and see if that's correct. 2 times 3 is 12. Whoops, 2 times 3, did you guys catch that? I made a mistake. Let's try that again. 2 times 3 is 6. 3 times 3 is 9. That's my test. These two are equivalent. Now I'm going to try to be tricky. Now I am going to go over to a white space here. I'm going to try to be tricky with you guys here. I get the feeling if you're listening, you're saying, I don't think you can trick me. So we're going to test this new fraction that I put out. I'm taking away the bars. We're going to test to see if these two fractions I give you are equivalent. And we don't have to be nervous about not having the bars because we can use multiplication to help us solve. I'm going to put an equal sign here, but you guys are going to help me if this is true. Okay, this. All right. We need to see if this is true. Is 4/12 equivalent or equal to 8/36? We don't have the bars anymore, but we know we can use multiplication to help us figure out if they're equivalent. Does anyone have an idea for me? You don't have to start on the numerator. I don't, for some reason, I just always start on the numerator. I'm thinking to myself, 4 times what equals 8? This will be our test. There is something times 4 that is equal to 8. Very good. 4 times 2. All right, so our test is if I can also multiply the denominator by 2, we've got an equivalent fraction. So I'm going to test this out. Is 12 times 2, remember we're multiplying the same value on the numerator and the denominator, is 12 times 2 equal to 36? If you said no, you're correct. Actually, 12 times 2 equals 24. I see. Yes, I'm going to erase this because what I'm seeing is actually 12 times 3 equals 36. So if I am multiplying a different value by the numerator and denominator, we cannot say that's equal. So it's kind of a nice little trick here. If you draw a line through the equal sign, that means not equal. These two fractions are not equivalent, and we didn't need any bars to help us figure it out. Before we move on to the next part, I just want to show you we can also use division. Maybe you already figured that out. So if actually, I'm going to come back over here. 2/3 and 6/9. Let's see if I remember that. 2/3 and 6/9. I actually remembered it. I'm very proud of myself. Now we used multiplication, right? 2 times 3 equals 6 and 3 times 3 equals 9. Okay, we know they're equivalent. We can also use division. That'll come later when you simplify fractions, but it's kind of fun to know that if we divide, of course, we'd start with the biggest digit, 9. What would we divide 9 by to equal 3? Okay, I'm seeing a 3 right here. I would absolutely divide 9 divided by 3 equals 3. We already know it's equivalent, but let's just test it. If I divide by the same number, is 6 divided by 3, is that equal to 2? Would you give that a thumbs up, or did we make a mistake? It's still equivalent. So you can multiply or you can divide. I find multiplication just a bit easier, but we can definitely use both to figure out if they're equivalent. Now this page I think is kind of fun. Let me see if I can find it here. Well, you guys can't see that, can you? This one here, if you were with me, sitting next to me, I would say, are these fractions equivalent? So our choices are to put an equal sign. Whoops. Let's try that again. That would mean, yes, they are equivalent. They are equal. Or our choice would be to draw a line between that. No, they are not equivalent. They are not equal. So I'm going to give maybe just about 10 seconds. I know that's not a ton of time, but a little bit of time to think. We have 2/8 and 1/4. My question is, are these two fractions equivalent? Since it's our first one, I'm just going to kind of do a little hint here. You don't have to write these, but it's just kind of a way to remember the steps until you've got them down. So we could either say, yes, they're equivalent. I see a yes with an exclamation point even. They absolutely are, but let's check it. This one we had to use some division because I actually started with multiplication and then I went, oh no, 2 times what equals 1? Okay, we need to do some division. So maybe you guys caught that too. So we can start here. We can say 2 divided by 2 equals 1. My hope is if 8 divided by 2 equals 4, they're equivalent. We can definitely say these two are equivalent. So now let's move down. Okay, this is equivalent. Let's look at number 2. So I have 1/3, I have 2/6. Can we do our math? Can we use our multiplication? This time I'm going smaller to bigger, so I definitely can use multiplication. give it a moment and decide, is it true that these are equivalent? Okay, in your head or in chat, say yes or no. Let's just test it really quickly. So if I do my little test here, I know I'm going to multiply 1 times 2 equals 2. Always let me know if I make a mistake. Yes, absolutely. Absolutely. I'm going to show that as well. Yes, you absolutely could divide. Excellent comment. And I'm just using multiplication, but you're right. We could divide, and I'll show that here in just a second. I'm sticking with multiplication just for a moment. I multiply 2 by the numerator. I need to multiply 2 by the denominator. 3 times 2 is 6. Yep, this is equivalent. So the comment I got was we could divide. Yep. Very good. Very good. So a comment I got that I want to address here really quickly, because it was a smart one, is you can also divide. So I could take the larger, yeah, I knew it was a typo. I was just waiting for that to come up because you were responding to me and I knew that was a typo. So 2 divided by 2 is 1. Yes, very good. And then we could also say, well, 6 divided by 2 is 3. Either way, they are equivalent. Now, let's try number 3. I'm just going to be quiet for a few moments because I don't think I've been quiet much to let you guys think. Take a look at number 3. Investigate that. Could you put yes, that's equivalent, or no, not equivalent? Okay. If you said no. Yes, if you said no, you're absolutely correct. It's not equal. Now, at first I thought it was. I thought, oh, 5 and 10, easy. 5 times 2 is 10, or we could think 10 divided by 2 is 5, either way. So I thought we're golden. But then I went, oh, if I'm going to multiply the same value by the numerator, I think I'm in trouble because 3 times 2 definitely is not 4. So I'd put, no, I'm sorry, friend, you are not equivalent. So as we continue to do this, I'm going to move down to number 4. Think through how we can test whether they're equivalent or not. Actually, let's just do one last problem because then I have a question for you before you go. So number 4, at first I'm thinking, yep, these are equivalent because I know 7 times 2 is 14, or I know 14 divided by 7 is 2. 14 divided by 2 is 7, if you caught me on that. 14 divided by 2 is 7. But if I come up here to test it out, 7 times 2 is clearly not 13/14. What could we change this numerator to? So we could make it equivalent. I wonder if I can see if I can white this out here. What could I change the 13 to make this fraction equivalent? Well, down here, 7 times 2 is 14. I'd have to have the same. 7 times 2 is 14. Excellent. So before we go, think about how you would describe equivalent fractions to someone who it was, does anything divided by 1 minus a quarter to the original number? Does anything divided by 1 minus a quarter to the original number? I'm not quite sure what you're asking. Does it have to do with the fractions? I just want to make sure I understand. I think, I'm not sure if this is what you mean, but one thing I have had kids ask about ones is like, we could divide by 1, but if I had 5/8 and that's actually a really good question. I could divide by 1, but then what is 5 divided by 1? That's 5 again. What's 8 divided by 1? Well, that's 8 again. So we would get the same fraction over and over.
Thank you so much, Georgia, for sharing with how to be able to find this way of being able to find equivalent fractions. There's two different methods that you can use. Three if you actually are coloring out different blocks or you actually have a physical, like candies that you're dividing. So you can be able to figure out equivalents. So let's say you had a bunch of chocolate chips and a bunch of Hershey's chocolates that are bigger than your chocolate chips. That would help you to be able to figure out how many chocolate chips are equal to one Hershey's. So helpful if you have a lot of different candy, you have to divide between different siblings.
Thank you so much. I appreciate everyone's time.
So, if you guys want to join them for an introduction to third grade math on October 10th, I'm going to go ahead and drop the link. You can have your mom or your dad sign up for you so that you can be able to get more of this really fun math classes. And then I also want to share if you guys are learning fractions right now, they do actually have a fractions workbook that goes over a lot of these different methods for being able to figure out fractions and learn about fractions. So I went ahead and dropped a link to that as well. So I really appreciate Georgia for coming on here and sharing with us about how to be able to figure out equivalent fractions.
Thank you so much.